Hello, this is chapter 15, part 1. This is the first day of random variables. All right, so today we're really going to focus on how to look at the expected value or the center of a random variable. And we're going to discuss some definitions to begin. First, a random variable. So a random variable assumes a value based on the outcome of a random event. And if you recall, a random event is something in which we know all possible outcomes, we just don't know what will be the outcome. Some notations. So we usually use a capital letter like X to denote the random variable. Okay. When we have a particular value, we will use the lowercase letter, in this case X, to be that value. There are two types of random variables, discrete random variables and continuous random variables. Discrete random variables, I like to think of things that I can count. And continuous ones are things that can have any numerical value within a range, so things I can measure. So basically, discrete ones are things I can count, and continuous are ones I can measure. Now, we would like to develop a probability model for this random variable, and then remember, I have to have all possible values, and I need to list the probabilities. So as such, remember, each probability has to go between 0 and 1 to be valid, and the sum of all of the probabilities has to equal 1. Okay. So of particular interest is the value we expect of a random variable to take on. We will denote that as mu, which is the population mean. Now remember, we call that the population mean because we know everything that could happen. That's why we use the Greek letter mu. We will call that E of X to represent the expected value for that random variable. And thus we get our first formula. To find the expected value, we simply multiply the outcome of the random variable times its probability and then add all of those things up. Okay? Remember, we need to make sure we have every possible outcome to make sure that the sum is correct. Okay? Also remember that you have a valid probability model to start with, meaning all probabilities are between 0 and 1, and the sum of all probabilities is equal to 1. Okay, so we're going to start off with example number 1. Find the expected value of each random variable. So here's the random variable. These are all possible outcomes that could occur, and these are the individual outcomes and their associated probabilities. So the expected value of X is going to simply equal the sum of each X times its probability. So the first X is 0 times its probability plus the second X, which is 1, times its probability plus the third X, which is 2, times its probability. All right. Now, I'm just going to go ahead and add that together. That's 0.5 plus 0.4, which is going to give me 0.9. Now, you can do this on the calculator by going to Stat, Edit, entering these values into your lists. So you're going to hit clear, enter. Go to L1, clear, enter. Now, the order matters. So L1, you always put in your X values, 0, 1, and 2. And in L2, you put your probabilities, 0.3, 0.5, and 0.2. And then you hit enter. You hit stat, you hit calc, you hit one bar stats. It should be L1 for your list, and frequency list should be L2. You hit calculate, and the very first value at the top, X bar, is your expected value, 0.9. Now, on Edpuzzle, please go ahead and find the expected value for part B and enter your answer that you found. All right, welcome back. All right, so just to verify what you should have done, the expected value of X was equal to 100 times 0.1 plus 200 times 0.2 plus 300 times 0.5 plus 400 times 0.2. Okay. And then if you went ahead and did this on the calculator, you should have got 280. Right. All right, so for example 2, a coffee shop tracks sales and has observed the distribution in the following table. What is the average daily sales that it can expect? All right, so this is your random variable, and these are the probabilities. So on Edpuzzle, please enter your expected value. All right, welcome back. So to show your work here, expected value, you should have got the following: 145 times 0.15 plus 150 times 0.22 plus 155 times 0.37 plus 160 times 0.19 plus 170 times 0.07. Okay. To review on the calculator, you should have went to Stat, Edit, cleared your lists, in L1 you enter 145, 150, 155, 160, 170. In L2 you enter 0.5, 0.22, 0.37, 0.19, and 0.07. You hit Quit. You hit Stat, go to Calc, enter 1-bar stats. X list is L1, frequency list is L2, and you hit Calculate. And your expected value is 154.4. And you're done. All right, so for example 3, so this is slightly different in that we have to actually create the probability model first. So you roll a die. If it comes up with a 6, we will win $100. If not, we get to roll again. If you get a 6 the second time, I win $50, and if not, we lose. So we're going to create a probability model for winning. Okay. All right, so we have amount of winning and then probability of winning that amount. All right, so for the first case, I can win $100 if I roll 6. That's only going to happen 1/6 time. Okay, otherwise I roll again and then I can win $50. Well, in order to roll a second time, I had to have lost on the first time, and then I have to win on the second time, and that's how I get 5 out of 36. And then on the third one, I just lose. So in order for that to happen, I have to lose on the first time, and I have to lose on the second time, and then I get 25 out of 36. All right, find the expected value. So the expected value that I'll win, I simply go to the calculator, Stat, Edit. I clear my lists. Right, L1, I'm going to put my money I'm going to win. So I have $100. I have $50. I have $0. Probabilities, I have 1/6. I have 5/36. And I have 25 over 36. Quit. Then I have Stat, Calc, enter on 1-bar stats, L1 and L2, calculate. So my expected winnings will be $23.61. How much will I be willing to pay? Well, anything less than what I'm going to expect to win. So anything less than $23. All right, example 4. So this one's a little bit more complicated. So a carnival game offers a $100 cash prize for anyone who could break a balloon by throwing a dart at it. It costs $5 to play, and you're willing to spend up to $20 trying to win. You estimate that you have about a 10% chance of hitting a balloon on any throw. Okay, so here's the number of darts that we're going to throw. Here's how much I'm going to win, and here's that probability. All right, I'm going to try to make this as neat as possible. All right. Okay, so first one, I throw 1 dart. All right, $100 cash prize, but it costs $5. So I will win $95 on that first dart if I win. I have a 10% chance of winning, 0.10. All right, let's say I didn't do that, so I have to throw another dart. So I have to pay another $5, so I will end up winning $90. So that means I had to have lost on the first one, and then I will win on the second one. All right, now I'll go try a third dog. I pay another $5, so I subtract another 5. All right, I lose the first 2 darts, and then I win on the third one. All right, fourth, okay, and I could win. I get $80. So I have to lose in the first 3, and then I have to win. Now, I will only spend $20. Here's my $20 I've lost. That's my 4th dart, okay? I'm not gonna throw a 5th dart if I've lost. And that means I would have lost on everything up to that point. And there it is. So expected number of darts. So what I'm going to do for expected number of darts is I'm going to plug them into the calculator, L1 and L3, this one and this one. And you should get 3.44. For your expected winnings, what you're going to do is do the same thing, but this time do winnings and probabilities, and you should get an expected winning of $17.20. All right, and last but not least, a man buys a racehorse for $20,000 and enters it in 2 races. He plans to sell the horse afterward, hoping to make a profit. If a horse wins both races, its values jump to $100,000. If it wins one race, it'll be worth $50,000. If it loses both, it's only worth $10,000. There's a 20% chance it will win the first race, a 30% chance it will win the second race. The races are independent. All right, so profit, probability of making that profit. All right, so best case scenario, horse wins both races, 0.2 times 0.3. It'd be worth $100,000. However, he had to have paid $20,000, so he's only going to really make $80,000. Okay, could win one of the races. So first race wins, second loses, or loses the first and wins the second. And it's worth $50,000, but remember, you paid $20,000, so you're really going to make a profit of $30,000. All right, last case, loses both. So 0.8 times 0.7, and that's going to be worth $10,000, but you paid $20,000, so you really lost $10,000. So what is your expected profit for this horse? Let's check that out. Stat, edit, go up L1 and L2. I'm going to clear both of those lists. And then we have 80,000. That's enter. We have 30,000. And then we have negative 10,000. And then we have 0.2 times 0.3, enter. 0.2 times 0.7 plus 0.8 times 0.3, enter. 0.8 times 0.7, enter. And then I'm going to quit. Stat, calc, one of our stats. L1, L2, calculate. And my profit is $10,600. All right, there you go.